Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos like this. Salamat! Today we're going to talk about the voltage regulation of alternator. This is the part 2 of our discussion about the voltage regulation. So again, the percent voltage regulation is the percentage rise in the terminal voltage of a generator when its load is removed. The smaller the value of the voltage regulation of a synchronous generator or simply alternator, the better is the performance of the alternator. So mathematically, the percent voltage regulation is equals to the no load voltage minus the full load voltage all over the full load voltage multiplied by 100%. Or simply, it is also the generated voltage minus the terminal voltage all over the terminal voltage multiplied by 100%. Because the generated voltage is equal to the no load voltage when there is no load. Okay? And the terminal voltage is equal to the full load voltage. And note that these values, these voltages are phase voltages. So again, these are our equations, the generated voltage when we have the lagging power factor, the leading power factor, and for unity power factor. So we're going to use this same equation. So again, the generated voltage will be the no load voltage. So an alternator operating at unity power factor has a small positive voltage regulation. So that is the relationship between voltage regulation and the power factor. When it is operating at a lagging power factor, it has a large positive voltage regulation. While an alternator operating at lower leading power factors, the voltage rises with increase of the load and hence the voltage regulation is negative. So for a certain leading power factor, the full load voltage regulation is 0. In this case, both the full load and no load terminal voltages are the same. So let's have practice problem number 1. A 1200 kVA, 6600 volts, Y-connected synchronous generator has a 0.25 ohms resistance and synchronous reactance of 5 ohms per phase. Find the percent voltage regulation at 0.8 lagging power factor. So we can write the given first. The apparent power is 1200 kVA. The line voltage is 6600 volts. The power factor is 0.8. The armature resistance is 0.25 ohms. And the synchronous reactance is equals to 5 ohms per phase. So we are asked to solve for the percent voltage regulation. First, we have to determine the angle theta using our power factor, and that will give us 36.87 degrees. And solving for the phase voltage, we simply divide the line voltage by square root of 3. This will give us 3,810.51 volts. So this is our terminal voltage. So solving for the phase current, that is simply the apparent power all over 3 multiplied by the phase voltage, this will give us 104.97 ampere. And this is our phase current. So using our equation for the lagging power factor, we simply plug in all the values doon sa ating equation for lagging power factor. Our no load voltage will become 4,166.06 volts. This is also our voltage, the generated voltage, I mean. So having these values, we can substitute, we can use our equation now for the voltage, the percent voltage regulations. We simply plug in the values for the no load voltage and the full load voltage. Then our voltage regulation will be 9.33%. Practice problem number 2. A 3-phase 10 kVA 400 volts star-connected synchronous generator supply the rated load at 0.8 lagging power factor. Find the percent voltage regulation if the armature resistance is 0.5 ohms and the synchronous reactance of 10 ohms. So first, we're going to write all the given values. Then we are asked to solve for the percentage voltage regulation. So for our solution, again, we're going to determine or to compute for the angle theta and also compute the phase voltage, simply dividing the line voltage by square root of 3. This will give us 230.94 volts. So this is our terminal voltage. And again, solving for our phase current using the apparent power all over 3 multiplied by the phase voltage, the phase current will become 14.43 ampere. And using our equation for no load voltage in case of lagging power factor, we simply substitute all the given values and the solved values, the computed values rather, in our equation. Then this will give us 341.85 volts for our generated voltage or the no load voltage. So using these values, we simply substitute to our equation, then this will give us 48.02%. So napakataas ng voltage regulation. So hindi maganda ito kasi naaapektuhan nito yung overall efficiency. So parang ano sila, no? Ibig sabihin, there is a poor voltage regulation kapag ganito kataas. Dapat mababa lang talaga, siguro 5% below lang talaga dapat ang voltage regulation. Okay? So hindi maganda yung performance ng alternator na to pag ganito kataas. Okay, for practice problem number 3, a 1 MVA 4.6 kilovolts Y-connected alternator has an effective resistance of 2 ohms resistance per phase and synchronous reactance of 20 ohms per phase. Find the percent voltage regulation at 0.75 leading factor, power factor, I mean. So let's write all the given first. Then solve for the voltage regulation. So again, so we compute for the angle theta. That will give us 41.41 degrees. Next is compute for the phase voltage. This will give us 2,655.81 volts as our terminal voltage. Then again, solving for our phase current. So that is apparent power all over 3 multiplied by the phase voltage. And this will give us 125.51 ampere. So that is phase current. So we're going to use now the equation for the no load voltage in a leading power factor. So papansin nyo dyan na nag-minus tayo rito sa loob. So substitute all the values given and the computed values for the no load voltage and the phase voltage. Then, I mean the full load voltage or the generated voltage. So the no load voltage or the generated voltage is 2,367.3 volts. Then substitute these values to our equation to get the voltage regulation. This will give us negative 10.86% voltage regulation. So that's all mga ka-wisdom. Again, kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video to. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Thank you!